Hello everyone, I'm Gauri Krishna. I'm a third year student in Harvard University. So today we will see fifth experiment in triangulation. Uh, so, so this is the fifth experiment in NLT, which is multi-layer perceptron using voltage. So the aim was to develop a multi-layer perceptron model using a voltage for classification using the breast cancer dataset. And evaluates the performance using accuracy, precision, recall, and reference data. So, so in this experiment of implements for multi-layer system using a PyTorch for the binary classification on the breast cancer dataset. And the goal is to identify classify the tumors as malignant or benign and evaluate the model performance. So the first one question is to read the answer. So in this step, I've loaded the questions dataset using SQL. And this dataset consists of 569 samples and 30 numerical features related to the tumor characteristics. And this dataset also provides feature names and target labels. And the second question is, to select the X and Y parameters. So independent variable, we can take X as the independent variable and Y as the dependent variable. So independent variable means all input features and Y means the independent variable, which is the target labels. So X is used to train the model and Y is used to compare the predictions. The third question is the standardization question. So here in this step, I used the standard scale to normalize the data, and standardization transform the data such that the mean equal to 0 and standard deviation as 1. So this improves the model performance because neural network works better when all the features are on the same scale. In the question 4, it is basically we the first split. So here I split the data set into the training and testing. So training is basically 80% and testing is 20%. So the training data is used to train the model, while the testing data is used to evaluate the performance of unseen data. And the question 5 here we convert it into a PyTorch pencils. So in this step, I converted the data into a PyTorch pencils. So this is required because PyTorch models can only process the data as sensor data. So here the plot pencil is there and long pencil is there. Plot pencil is basically for input features and long pencil for target labels. We got the output like this. And then question 6, it is basically define the NLP architecture. Uh, and I designed a multi-layer perceptron with the multiple hidden layers. So the architecture is basically like input layer of 64 and hidden layers are 32, then 16 and 8 neurons. Then output layers, so 2 neurons. And yeah, so here the activation RU activation is used between the layers to introduce this the structure will helps the model to learn the complex patterns. So this is the output we got. In question 7, it's basically train the model. In this step, I train the model using uh, the loss function and optimizer. So forward pass, loss calculation, back propagation, and weight update. These are the steps, training steps that involves here. So forward pass means the model predicts the output, loss calculation, compare the prediction with actual. In back propagation, it will calculate the gradients, and weight update means it will improve the model. And this process is repeated for like 100 box to minimize the error. And in eighth one, it's basically plotting a curve, training curve. So I plotted a graph like x-axis is number of iterations and y-axis is training loss. So this graph helps visualize like how the model is learning. This will tell us. Here we can see a decreasing curve, which indicates that the model is improving over time. Yes. And in question 9, it's basically testing the model. In this step, I tested the trained model on recent data. So this model predicts the class variance for the test inputs, which are then compared with actual values. And then question 10, it's basically the performance evaluation. Performance evaluation means I evaluated the model using a confusion methods and a performance methods. So accuracy, you can see accuracy, precision, recall, and score. So accuracy means the overall correctness, and precision tells us the correct positive predictions. Recall means its ability to find all the positive values. F1 score, it's the balance between precision and recall. It's basically the harmony mean between the precision and recall. So yeah, these metrics help us to understand how well the model performs. So yeah, these are all about the fifth experiment in emulating. So yeah, we can tell that the NLP model achieved high accuracy and distance dataset. Uh, thank you. That's all about that's all about this experiment. Thank you so much.